This this video brought to you by, I think this is an Django guy, and he's one of these double head things. Ooh, he's angry. And yay, he's happy, and he's got a band-aid on his face and a scar somewhere. Okay, so we got two last questions, or two last examples for these solving these trig functions. Thankfully, this one is giving us an interval over which we have the solutions. Note we're to do both a graphical and an analytical technique. I always advise my students to do this one first so you know the answer, and then go do the graphical method and see if you get, or sorry, the algebraic or the analytical. Oh, and there's how you spell algebraic, the analytical method. But I'm going to not do that since I know the analytical methods, and I'm going to start with that and then confirm it with our graph. These last two examples look at other types of tricks you might have to do in order to get your trig equations into the form trig equals something. So if you look at this, is there a way we could combine these values? Well, we can't because this is a squared and this is not a squared. We could factor out a cosine, but that's only useful if it's equal to 0. So I'm going to subtract 3 from both sides, and I'm going to note that this equation is in quadratic form. In other words, if I let y equal cosine of x, then y squared would be cosine squared x, and I could rewrite this equation using those values as y squared plus 2y minus 3 equals 0. Why is this useful? Because I can easily solve this quadratic. And I know easy is a terrible word for a math instructor to use, but at this point in your math career, this should be an easy equation. Maybe not necessarily going from here to here, but solving this quadratic, you have so many ways to do it, you should just be able to do it quite quickly. Quadratic formula always solves it. That's too complicated a method. This is factorable. This is one of the nice, easier factor ones because this is a 1. I know I keep using that word easy, but really, you all, as you're getting closer to your calculus career, you want this part to be snooze alert. All right, so note I factored it. I'm looking for factor multiples, numbers that multiply to -3 and add to 2. And so I get y equals +1 and -3. Well, that means that doesn't mean anything yet. Recall that we're solving for x, not for y. So we go back to what we said y was equal to, and note we now have two trig equations to solve. Cosine x equals 1, cosine x equals -3. Notice this got what we desired at the very beginning, trig equal to some number. So this, both of these are just solved by taking the inverse function of both sides, remembering that your why does it say x? Remembering that your calculator may not actually give you all the solutions within the interval required because cosine inverse has a restricted range. All right, note that this one is undefined, or no real solutions. -3 is outside the domain of cosine inverse. If you think about what cosine can be, it can only be numbers between -1 and 1. So no solutions here. Just say no solutions. Over here, we know this one, right? Go to your unit circle. Where's x1? It's right here. So we know it could be 0 and it could be 2 pi and any multiple or any coterminal angle with 0. 2 pi happens to be coterminal with 0. Well, look at the restricted interval. We only want angles between 0 and 2 pi. So the only solution to this equation is x equals 0. That was wonderful. All right, let's do the graphical method. So this was the analytical. Now graphical. Let's get our divider there. And what do we want to do? Let's do, just because, whatever, let's do the intersection method. That means I'm going to graph y1 as cosine squared x plus 2 cosine x. Sick of making typos. And y2 is going to equal 3, and we're just going to find all the places those intersect. So here comes Desmos. Oops, that's not Desmos. Oops, that's not Desmos. Here's Desmos. And note we could actually type y1 if we wanted to. Cosine squared, does this work? X plus 2 cosine of x. Now, is it handling it properly? Let's check. Yes, it is. What a wonderful graph. And then y subscript 2. You could use function notation. You could just use y. It doesn't particularly matter. Equals 3. And we have to use y equals 3 for this particular one. And here's all of our solutions. Note, they go on forever and ever and ever. What? I'm wrong? No, I'm not. Stop. Notice 0 and 2 pi. For some reason, my brain was saying 2 pi thirds. So this is not a solution because that's outside the interval of interest. This was our only solution, x equals 0. So my graph should reflect the basic image you're seeing here. So this little thingy, and then this should be x equals 0, and this should be 2 pi. I am not a real strict person in terms of how pretty your graphs are. They should just have the basic shape and a few of the characteristics of interest. So I might even toss in these places where it intersects the x-axis just to feel like I had really done my work. You should always listen to whatever your particular instructor says. Do they prefer really detailed graphs with nice tick marks, or is this good enough? I mean, oh, this is not good enough because you're not showing the second line, that side. One other thing to note here, I have had students do this. They graph the equation, and Desmos actually handles that. And it shows, does it? Let me try this. Oh yeah, it doesn't do it. Okay, for some of them it would do it. Sometimes, so for whatever reason, Desmos is not doing that. Oh, you know why it's not? It's because it's the only solution is right here, so you can't even see it. Wonderful. Okay, let's look at the second problem in the last example problem. Again, 2 methods. Note the interval is a little different. It's non-inclusive, negative pi to pi. So here we have cosine of pi minus x plus sine of x minus pi halves equals 1. Ooh, that's a huge problem because it's going to be a little difficult to get this to be a trig equals a number. But actually it's not, because you have a bunch of handy identities. I've got to find mine. And we're going to rewrite either cosine in terms of sine or sine in terms of cosine. So for this one, we're actually going to use 2 identities. The first one, I think, well, you know what? Let's just do this the really difficult way. I'm going to go ahead and use my sum and difference identities for both of these, even though I should really be able to use one of these identities and rewrite it. Actually, okay, stop it, Eric. Let's just do one of these. So look at this. This is sine of x minus pi halves. This is sine of pi halves minus x. Is there going to be any difference between these two? And the answer is, boy, I don't know right offhand. So here's how we're going to tell. I should know this. If Allison is watching this movie, please laugh at me. So here's sine of x minus pi halves, which is the one that's in the equation. Here's the identity that we said this is equal to x, or cosine of x, and that was sine of pi halves minus x. Oh, they're not the same, but don't they look like opposites? So what if I was to graph negative cosine of x? Would we get that purple graph? We don't. What if I was to graph cosine of x? Oh. So, okay, so here, what? So here's what we've shown. We've shown that the green line is equal to negative cosine of x. So sine of x minus pi halves is negative cosine. And then sine of pi halves minus x is equal to cosine x. So we can get back to our expression here, and we said that sine of x minus pi halves is negative cosine of x. Okay, so we've accomplished one task. Now I'm going to do the hard way. I could do that same line of reasoning to figure out what this is equal to, but instead I think it's a good review of these sum and difference identities. I'm going to apply this sum identity. So this cosine of pi minus x is really cosine of pi times cosine of x minus sine of pi times sine of x, and then don't forget we had this minus cosine x here. This whole mess was equal to 1. Okay, so what is cosine of pi equal to, and what is sine of pi equal to? Well, let's grab our unit circle real quick. Let's take a look at this being pi as a radian measure. The x value is -1, fail, and the y value is 0. So this is -1, and this is 0. Well, 0 times anything means that's all gone. And then -1 times cosine means we get negative cosine x minus cosine x equals 1. Well, those are like terms. Maybe you recognize that, maybe you don't. They have coefficients of 1. -1 minus 1 is -2 cosine x, which is equal to 1. Divide both sides by -2, and we get cosine x equals -1/2. Oh, glory days, we are there. Take the inverse of both sides. And this would be our solutions. Now, we got to go to the unit circle and figure out are the angle values for cosine being 1/2. Recall that we've restricted our domain to be negative pi halves. Oh, why am I putting negative pi? Yeah, negative pi halves to pi. So that is this set of values where we're going in this direction. So here's negative pi half. Wait, what? Negative pi. Yeah. Oh, okay. Well, I'm going to come back to that. And let's just figure out where's cosine a positive 1/2. So it's going to be here, and it's going to be here. So this is 1/2 root 3 over 2. Fail. This one is negative 1/2 root 3 over 2. So actually the other positive 1/2 one, nope, it's not there. It's here with a y value of square 3 over 2. Okay, so what are these values? Well, I know this one happens to be pi thirds, and if I were going in this direction, this one would be, what is that, 5 pi thirds? But because of our restricted domain, we actually have to go this way to find it, which would be negative pi thirds. So our two solutions are pi thirds and negative pi thirds. Those are the two values that are within this restricted domain. Boy, that was painful. All right, let's do our graphical method. Let's do the intersection method this time. So let's see, we're going to do this mess. We'll write graphical so you know that I'm now doing it. And I'm going to graph cosine of pi minus x plus sine of x minus pi halves minus 1 equals 0. And we're going to graph this, and then we'll draw the graph here. So let's switch to Desmos. Let me just grab a new graph here. And here we go. Cosine, by the way I'm getting pi in here is I'm typing pi. If you wanted to find it, oh, it's right there in your number pad. So this is minus x plus sine of x minus pi divided by 2, and all of that added to 1. By the way, look at what happens if I put equals 1. What is this mess? So don't do that. Get that garbage out of here. And equal 1. So this is our one side, and then here are all our solutions, right? along with my analytical methods. So we have to be between negative pi and pi. So I'm going to type in x equals negative pi, and I'm going to type in x equals positive pi, and now I'm going to grab all of the places where it crosses the x-axis in between those, and it's negative 2 pi thirds and 2 pi thirds. So we're going to have to go back to my mistake and fix it. Oh, I see it already, and you probably saw it from the beginning and were screaming at me through the video. You poor man, you didn't notice the negative, and I will thank you for saying that. Although most of the time students in my class wait till I've solved the entire problem and then tell me, hey, you made a mistake there. It's an exercise in humility. Good exercise. Okay, so here's our graphical method. We're going to go back and fix my analytical method real quick. This is what I graphed. I guess I should have put these maximums in here, but whatever. Got my minimum. So my solutions are x equals negative 2 pi thirds and 2 pi thirds. So going back to my solution, here's my mistake. I wrote negative 1/2 here, and I didn't write it there. What a shame. So I'm going to cross all of this out, and I'm going to redo this solution. X equals cosine inverse of negative, thank you for not screwing up this time, negative 1/2. Now I'm going to draw my unit circle again, and I'm going to note all of the places where x is negative 1/2. It's going to be here-ish and here-ish. So my coordinates here, it's negative 1/2, negative square root of 3 over 2, and here it's negative 1/2, positive square root of 3 over 2. Now my angles are between negative pi and pi. So here's an angle that's less than pi and greater than negative pi halves. That's my 2 pi thirds. And this angle going in this direction would be negative 2 pi thirds. All right, if you want to email me all my mistakes and you're not in my class, here's my email address. Feel free to email me. You can also comment in the YouTube videos on all of these mistakes and help me fix them.